They are carrying secrets of our origins, waiting to be deciphered by scientists in laboratories around the world. Each one is a direct sample of the building blocks of planets, offering a tangible connection to the processes that shaped our solar system. Holding one is holding a piece of history, a fragment of a story that spans billions of years and countless cosmic events. The iron meteorites are the heavyweights of the meteorite world, dense, metallic, and unmistakable, made mostly of iron and nickel. They're much rarer than stony meteorites, but easier to spot. These are fragments of the cores of ancient shattered worlds, planetesimals, that once melted and separated into layers. When cut and polished, iron meteorites reveal the stunning Vidman-Stetter pattern, a crystalline structure formed by millions of years of slow cooling in space. This pattern is proof of their extraterrestrial origin. Studying iron meteorites gives us a glimpse into the cores of planets, something we can't do on Earth. They're pieces of lost worlds, offering clues to the violent processes that shaped our solar system. More than curiosities, they're windows into planetary interiors. Each one is a testament to the creative chaos of the cosmos. The rarest and most beautiful meteorites are stony irons, a blend of rock and metal. They formed at the boundary between the metallic core and rocky mantle of ancient asteroids. The most stunning are pallasites, iron nickel studded with gem-like olivine crystals that glow like stained glass when sliced. Mesositerites, another type, are chaotic mixtures of rock and metal, fused by violent asteroid collisions. Stony irons tell stories of both creation and destruction, of worlds forming, colliding, and merging. They offer unique insights into planetary interiors and the dynamic history of the asteroid belt.